Good day, doctor. This is our group. Will be presenting the assignment for the concept and paradigm assignment to analyze OOP programming language.
This assignment is about the object-oriented programming languages such as Java and Python that are applied address book management and to-do list creation, etc. The focus remains on the fundamental OOP concept, ensuring modularity, reusability, and simplicity in development process. Our group has chosen a simple development application which is developed by Python. With that, we have chosen an example from GitHub which reserve a practical demonstration of object-oriented programming principle in Python. The project is designed to analyze and create an application that embodies key OOP features, providing on hands-on approach to understanding concepts such as encapsulation, inheritance, and polymerisms.
For the
Class
first
design
part
and
would be the
implementation.
class design
When we
and
analyze the
implementation.
code function,
So for this
we get
application,
to
it
know
has
that
three
there are three
classes.
classes
The
used
first
in the
class is
application.
expense class.
First
The
is
second class
application
is
expense
expense
class.
database class. The
Second,
third class
expense
would be
database
expense
class,
tracker
and third
class.
is
So
expense tracker
for the
class.
first part would be the class
So,
design. So in the first
so this
class,
is
which
the
is the
um,
expense
class
class,
design and
it
implementation for the
has
first part, which is the
a number
expense class.
of
So
attributes
in the
which
expense
are
class, we
ID,
have
title,
a few
amount,
attributes
and the
that's been
date that
declared
is
in the
created.
expense
So these
class,
are the
namely
attribute that
ID,
describe the expenses will
title,
be
amount,
inserted
create at,
by the
and
user.
update at. So
The
these
second class
are
is
the attributes
update
that
expense,
describes
which is
the
the
expense. So
in the
ID is being
expense
generated using
update expense
UUID
class.
function.
It has an
Title,
additional
it will
method to
be
update the
the string
title
format
or the
which will be
amount
inserted by the
whenever the
user. Amount
expense
will be a
a
float.
particular expense is being
Type
updated
created
with a
at will
new
be
timestamp.
using date
So if you
time
look closer,
now,
the
which is
timestamp would
a
be using
function
date time now,
that's
which is
from
a
the Python
Python using a
package,
Python library
and
to
update at will
fetch
be
the
the
current date based on the
using the
UTC
same
time zone.
function from the
So
self-create
in the
at.
first class,
Next would be
which is
the
the expense class,
update
it
expense
has
class.
a
Update
number of
expense class,
attributes
it
which are
uh,
ID,
it
title,
has
amount,
the
and
same
the date that is
uh,
created. So
it
these
has the
are the
same
attribute that describe the
set of
expenses will
attributes
be
from the expense
inserted
class,
by the
but
user.
however,
The
here we
second
can
class is
notice a few
update
differences
expense,
where
which
it has
is
its own method to
the
update the title and
in the
or the
expense
amount
update
when
expense
the
class.
timestamp
It
is
has an
refreshed.
additional method to update the title.
The third
The next
class
class
is
would be
expense
expense
database
database.
class,
So expense
and
database
in this
class, you can
class,
notice that it
this
has
class
self.expense
perform
with
the
a
collection
dictionary
of expense instance
dictionary
where
implementation.
it
So
provides
whenever
the method to
uh,
add, remove, or
the
query the
more than
expenses.
one expense
And
being
also
tracked, it
the
will
expense
inserted
database class
into a
demonstrate
collection
the
which will
core
store
object-oriented
all
design
the recorded
through the
expenses
implementation of
into a
its own
collection.
function.
So
Moreover,
the
it
next thing would
encapsulates a
have
private expense list
another function
and
which is
provide
add expenses,
a
where it
control
able to
access
print out the
through its
expense
own
with
public
its
method.
ID,
So
and
this makes
also there's a
the application handles
remove
data
expense,
protection by
and
providing
also
copies rather
get
than
expense
direct
and
references, which
get expense by
is
title,
able to
and next would
prevent
be the
unwanted
two
external
dictionary method.
modifications
So
from other
overall,
class. Moreover,
this expense
it
database
manages a
class,
collection of
it has
objects
the functionality
which
to add,
establish
remove, and query expenses,
has a
which
relationship
overall
which
it
is
demonstrates the core
follows the
functionality of
OOP principles.
object-oriented programming
So
language
these are
through
the
its
methods that are
implementation.
designed
So from this
for
class, it
specific tasks. For
encapsulates a
example,
private
adding
expense list
expenses,
and provide
which returns the
control
created
access to the
object,
main
removing
class,
the
where it
user's
will
efficient list filtering,
perform
and also
storing and
retrieving by ID
retrieval of
single
expenses
match or
whenever the
none.
user input.
We also notice
Finally,
to
the
ditch
whole
dictionary
application, it
method, which
able
enables
to handle data
serialization
protection by
in
returning
Python programming
copies rather
language,
than
which
direct
creates a
references.
robust
So
and
this
maintainable
makes
system for expense
this
management.
prevents unwanted
And
external
finally,
modification
we have
from
the
other
expense
classes.
tracker class,
So
which extends. To wrap up
expense
the whole
database
class
to
design and
add
implementation
interactive expense
of this
tracking
application,
functionality.
it
So,
manage a collection
from
of
the
expense
expense tracker
object
class, it
which has
has the
the
capability of adding
relationship
a
of has
user-facing
a.
feature
So this
through
has a relationship will be
inheritance.
performed used to
The
perform
track
specific tasks
expense method
such as adding
enables
expenses,
daily
which
expense
is to
logging
retain the
with
created object from the user,
validating the input
removing
from the
users
user, which
efficient list filtering,
the
and
user
moreover
have
it will
the
retrieve by ID,
ability to
return
input
single match
multiple
or none.
expenses with
So
title and
every
amounts.
expenses is being
And also final
matched
the
with an
display
ID.
expense method provides a
So this
formatted
is the
output
part for
for
class
all the
design
recorded
and
expenses.
implementation. The next
So
class would
this
be
is the
expense
part
database. So
for
expense database class,
class
you can
design and
notice that it
implementation. The next part
has
would be
served the
inheritance.
expense with a
Hello, my name is Mahmoud Musa Osman with the metric number 290863. So as after we had the class design and implementation, we start with the inheritance. You must be wondering what is inheritance. Inheritance is one of the key concepts of object-oriented programming. It allows a child class to inherit methods and attributes from a parent class, enabling code reuse and extensibility. This means we can build on existing functionality without rewriting the same code, which makes our application more efficient and maintainable. Inheritance is in a lot of programming language. We have it in Java, and like we're using Python, we have it too in Python also. So how does it work? The parent class is the core class actually, the core functionality, and the child class will extend as a customized functionality from the parent class. The benefit is because we can have the code reuse. It will avoid duplications of reusing a parent class, making our code very long. So it's kind of make our code look nice. And so extensibility, it adds new behavior to existing class. And lastly, modularity, which simplifies the code structure and maintenance in the future if you want to maintain it. So in our code, we first have the parent class, like I said earlier in the definition and telling you what's inheritance, which on display we have the class in our application. We have the parent class, which is the expense database class. It serves as the parent class. It focuses on core data management by providing essential methods like the underscore init underscore for initializing the expense, then the list, and sorry, the expense list, and add underscore expensive expense for adding new expenses. It's like the underscore init underscore it's analyze the expense list, while the add underscore expense is for adding new expenses. This class is foundational as it provides the basic functionality with that will be used and extended by the child class actually. So the purpose of it's manage the, like I said, the purpose is to manage the core expense or related functionalities. It stores and and retrieves the expense records. Then the key feature is the underscore init and add underscore expense. Underscore init underscore it creates an empty expense list, while the add underscore expense adds and confirm new expenses. So that's all about the code for the parent class. Next, I'm going to talk about the child class and its code snippet. The child class is named as the expense tracker. So the expense tracker inherits from the expense database, like you see from inside our code, which is the super. The super open bracket close bracket point underscore init, which create a list. They create the list of the expense list. It's like calling the parent up from up. So it's like the expense database is using the inheritance a core, like it's a core-oriented object-oriented program concept by calling the super. Like I said earlier, the child class will ensure it has access to all the attributes and methods of the parent class, while the expense database handles the core data. Expense tracker extends its functionality, focusing on tracking expenses over time and displaying the recorded data. So, for the purpose of the child class, it inherits functionality from the expense database, which is the parent class, and it adds new feature, which is to track expenses and reports it. While how and how it works, it's inheritance with the super open bracket close bracket, which is calling the parent class, ensures the child class and access and initialize class parent class attribute and method, while it extends functionality by adding custom features or tracking expensive, let's say. So that's all for the child class child class code, and that's how inheritance work, where you have a parent class and a child class, and the child can inherit the parents the parents futures, or so let's put it, or the attribute, the attribute. That's it.
Okay, so hello everyone. I'm going to continue about the polymorphism and interfaces. So polymorphism basically enables a single interface to represent different underlying forms, data type, classes. And polymorphism provides flexibility by allowing methods and functions to operate on objects of different types without knowing their exact class competence. And meanwhile, interface is a contract in programming that specifies that what method and class must implement without detecting how they should be implemented. It is a way to enforce a specific structure on implementing classes while allowing them to define their behavior. So this is the code snippet for the polymorphism. So what basically it does is, so let's take a look at the class at the coding first. So class expense tracker expense database definition underscore init underscore self, and then super dot init. So basically what it does is the track expense method in expense tracker add behavior specific to expense tracking, while it can still use all of the method of the expense database class, such as add expense and display expenses. This is a form of a runtime polymorphism where the derived class customizes or extends the functionality. So what we get here is the code snippet for the class expense interface (AVC). So basically for Python, it's easy for us to identify whether the code snippet contains uh, the interface module. So what we basically need is just the AVC, and then what the interface did do is to enhance consistency. So yeah, that's the thing.
So now we are going to look into the solid principle use case in the expense tracking application. So before we dive into solid principles, we have to know what are solid principles. So solid principles are acronym of single responsibility. The first one stands for the S, single responsibility. The O stands for open closed. L stands for list of substitution. I stands for interface segment segregation, and finally the D stands for dependency inversion. So we will dive into the use case of a solid principle used by the application. So the first one is solid the S, single responsibility. So single responsibility from the expense tracking application, we can look at the both the class expenses and the class expense tracker class. So the expense class is solely responsible for managing the individual expense data and its operation. And if you take a closer look at the expense database class, which is only handle the storage and retrieval of expenses, whereas it expense tracker manages the user interaction and expense tracking functionality. So each classes has its own functionality. It has a single responsibility to perform its task. The next uh, solid principle used by the application is list cost substitution. So in the expense database class, we can know that uh, the uh, this cost substitution principle, it's defined that the subtypes should be substitutable for their base types without altering the program correctness. So from the expense database, uh, that expense tracker inherits the methods such as add expenses and remove expenses. Also, when it inherits these methods, it does not modify the behavior. So this ensures that any instance in expense tracker can be used in the same place as expense database class. So this makes it the the whole application much more uh, much more concise, where every function being operate is very in a very seamless operation. So this is the solid principle use case in this expense tracking application.
Hello everyone, my name is Kishan and my matrix number is 297771. Now I'm going to talk about user interaction. This user interface code may refer to as how the program will interact with the user input based on the outputting responses. The interface should have an easy way for user to make an intention to be known to be programmed to track their expenses over the set number of the days. Although the program here is not a graphical one, the one that makes use of the command line interface can be seen here. Firstly, this is the code. The program introduces itself as a Python expense tracker in the first welcome screen. The user is prompted to enter their name, which is utilized to welcome them and personalize the engagement. This provides a welcoming and interesting atmosphere that motivates the user to keep using the application. After that, in this code, the user is asked to indicate how many days they would like to keep track of their spending. The application uses a try except block to handle invalid cases for an integer input. The application politely notifies the user and ends if the input is not a number so that the only valid input move to the next stage. It also alerts the user that the value must be bigger than 0 if the input is 0 or negative. Here, where the program builds an instance of the expense tracker class and calls the track expenses function with the specified number of days as an argument or once a valid number of the days has been provided. This creates the framework for keeping track of spending over the specified time frame. This is the code where within the method track expenses, the system calculates the given number of days. Then for each day, a recurring prompt appear in the form of dialog box asking the user to input the title and amount of expenses. Once the user input the word done, the loop is terminated for that day in order for the user to begin with the subsequent day's expenses. Expense objects are created using valid entries and are subsequently inserted into the database of the tracker. In the case where an incorrect amount is entered, an error is displayed and the user is given another chance to provide a valid input. As a result, this allows for a multiple expenses entry to be fluid and straightforward. Then, in this code, once the cost has been inputted, the recording user interface has been selected to present the entries. If no expenses were recorded in the previous intents, the program outputs a message saying that no such records exist. In the country, a number of all expenses permitted to be recorded along with their titles, amounts, and the ID tags on them is listed. This gives user of the application a detailed insight into the expenses they have been able to track. Okay. Finally, this is the code where the main execution block of the program evokes the main function. This encapsulates all over user interface and ensure the application runs well when executed. It keeps the user experience organized in a modular way for easy maintenance and expansion of the program. Thank you.
So we have finally come to the end of our presentation. So this is our findings of analyzing object-oriented applications, such as our case expense tracking application, which uses Python. And hope you guys like it. And thank you for listening.